This chapter is about getting the rate of return of several projects, several alternatives. When we have several alternatives, we cannot just go to every alternative, okay, and get its own exclusive rate of return. So in other words, I cannot go to alternative A, okay, and search for rate of return of A. And then I go to rate of return of B and search for it. Why? Because doing this, you are ignoring a very important fact, that there is money, okay, maybe it is not used. Unless I'm 100%, my total investment here is 40%, plus other factors. And here I'm using my total investment. But in real life, what usually happens, no, let's say I give you a good example like this one here. I have $90,000, okay? This $90,000, I'm investing it and it's giving me, let's say, 16%. All of a sudden, I decided to do another investment. So I took from $90,000, I took $50,000. And based on my study analysis, it's going to give me 35%. Okay, good. But where is the issue here? The issue here, $50,000, 35% is not the only investment I'm making, because there is $40,000 left and they are getting 60%. What's that 40,000? It is 90,000 minus 50. So I only use $50,000. There is another investment which I did not touch, $40,000, and it's getting me what, 16%. The second investment alternative, let's say a friend is offering me another alternative. He said, you know what? From that $90,000, let's open a grocery store, and that grocery store is gonna, let's say, give us 29% per year, and the investment needed $85,000. Also here, we should not be, we should be aware of what? It is not the whole investment, because my invested money that's available for investment, we said, we have $90,000 that's giving me what? 16%. So in reality, I still have $5,000 and the investment of it is 16%. So the second alternative is offering me $85,000, 29%, plus the money left. How much is it out of 90? 5,000. And that's calculated over 16%. So keeping in mind the available investment can tell me which one is a good investment for me. So it is not good enough just to tell me, hey, we have two alternatives, 35% out of 50, on 50,000, and I have a 29% on 85,000. Make the calculation which one is better for me. No, this is not acceptable. Why? Because you have to take into consideration the available, the total available investment. The total investment is not, it is not 85,000, it's not 50,000, it is how much? 90,000. So if you want to use 50,000 and you are going to get 35% on 50,000, you have to keep in mind the initial available investment. How much is it? $90,000. So what's left? 50,000 is used, then we have 40,000 left, and we can get on it 16%. So if I want to be precise, I have to say, hey, first alternative, which is A, alternative A, we are getting 35% on 50,000 plus what? Plus the left. The remainder, the money remained. How much the money remained? It is $90,000 minus the 50. So it is 40,000. And that money, it's it's available investment, and we are getting on it how much we said it's given 16%. So this is 40,000, 16%. You divide it by the total, so I can get the total percentage, the overall rate of return. So here I included my alternative plus the money that is invested, at MAR rate, okay? So the second one is what? It is the 85,000, okay? I'm getting 29% on it, plus the money left. What's the money left out of 90? 85, and I have 90, it's 5,000. And how much I'm getting on that? 16%. So the overall rate of return, including the MAR investment plus the alternative investment, is how much? 28%. Now I have a detailed picture of my investment, okay? Because I considered all the available investment, which is 90,000. For the first one, it gave me 26%. For the second one, gave me around 28%. For sure, what's better for me is to go with rate of return B, okay? If you want to look at it in a different way, let's assume, I have my money in the bank, and the bank, just an assumption, okay, for the sake of argument. Let's say in the bank I have 90,000, and the bank is always offering me 16% per year. If I want to open a business, that business is going to generate 35%, okay, if I invest how much? 50,000. Okay, so by the end of the year, I will be making $50,000 times 35%, plus what? Plus the money I'm getting from the bank, which is how much? 40,000, because this is, still in the bank, and the bank always giving me, interest on that. This is just an example. It's not 100% realistic, okay? So this is the idea of rate of return. This is the important of incremental rate of return. Why? Because in real life, okay, here I was able to know what's my total available investment. But in real life, I'm not going to know how much my total investment for every project. So what should I do? I will use incremental rate of return, okay? Incremental rate of return. If I use incremental rate of return, I don't have to worry anymore, hey, how much your available investment, okay? And this is very important. Let's get into some examples, okay? So we said, a quick reminder, okay, in order to get the correct, precise, rate of return, you have to consider what? You have to consider, the whole investment. And if I do not know it, we can go with what? With incremental rate of return. Just a quick thing here before I forget. If you see, guys, if you see 35% of investment, okay, I mean rate of return of 35% does not mean it's a good investment. Because 35% out of what? 35% out of 50, okay, it is not more than 80% out of 2, okay? So just being high rate does not mean it is accurate. So I have to know the total available investment, okay? Whether I have MARR plus the investment or the investment by itself. And that's why we go, with the incremental rate of return. How do we do this? How do we calculate incremental rate of return? It's very simple. Let's assume we have two alternatives, alternative A and alternative B. Okay, good. Okay, alternative A, it has first cost 40,000 annual cost 25,000, and it has a salvage value. Good. Alternative B, we have negative 60,000, 19,000 annual, and salvage value 10,000. Keep in mind that we do care about the sign, okay? Here it is negative because it's a cost. Negative 25,000 because they are telling me it's annual cost. If they tell me here it's annual revenue, revenue is what? Is positive, okay? You are making money. But they are telling me here annual cost, that means it is negative. Salvage value, that means the money I'm gonna get when I sell my alternative, because after I'm done from it, after 5 years, let's say, I have to get rid of it. Rather than throwing it away, I can sell it and make money. So here we have $8,000. It's positive. Okay, the second alternative also, we care about the sign, okay, whether it's negative or positive. Something you have to be careful about, you have to sort them, okay? What do I mean by sorting? We sort our alternative based on initial cost, okay? Based on initial cost, and that's what we have, okay, in this remark here. So we order them, okay? We order them by increasing initial investment. So when I look at alternative A, the cost is 40,000. Alternative B, the initial cost is what? 60,000. So I will put in the table A before B. I put them in an order. And as we said here, order alternatives by increasing initial investment cost. So which one is less costly than the other? Alternative A or alternative B? Based on the first cost, A is less cost than what? B. A is going to cost me $40,000. B is going to cost me $60,000. So you put A and all its payments and money before what? B. So this is the way the table has to look like, A then B. After you put them in order like that, and as I said, again and again, I repeat, order alternative by what? Increasing initial investment. You put them in order, not based on this, not based on salvage, no, based on initial investment, okay, the first one. After I put them in order, okay, A then B, because A is less than B, I'm paying less. So what do? I get the cash flow. What's the cash flow here? They tell us use B minus A. That means B is what? Is the initial cost of B is more than the initial cost of A. So we do B minus A. Okay, that's why we put them in order. B minus A. B is how much? Okay, where did I get this negative 20 from? Negative 20,000. Exactly, because here we have negative 60,000. Okay, let's just bear with me for a second so you can see it. I have B is, we say B minus A. B is negative 60,000. Then I have minus what? Minus 40,000. Okay. Okay, so now I have minus, this will be what? Positive, because minus. So now I have negative 60,000 plus, so now this is a plus, because minus will be a plus, okay? We are multiplying minus times minus, so it's plus. So now I have minus 60,000 plus 40,000 is how much? Negative 20. And that's why here we put what? This is the way we got negative 20. Same thing with this. We have negative 19 minus 25. That means negative 19 plus 25. We get 6,000. Okay? Same thing here. 10,000 minus 8. This is straightforward, so it's 2,000. After I get these, now I will get the rate of return of this column. Not A, not B. And that's why we call it incremental. Okay? We are subtracting B minus A, and we get the rate of return for both projects together. In some other chapters, we used to get what? Rate of return of a project A, rate of return of a project B. Here, what do? No, we get the incremental rate of return of both. Okay? So how we are going to do it, we are going to show you in a second. The rate of return, as I mentioned here, that we are going to get, we call it delta I asterisk. Okay, this delta I asterisk or star, whatever you want to call it. Okay, when this delta I is greater or equal to the MAR, then my investment is very good. Okay, when the rate of return, the delta I that I'm going to show you in a second, okay, it's greater or equal to the MAR, that means my investment is good. If it is less, that means it is bad investment. It is bad investment. It's not economically justified. Okay? Keep in mind that those are for mutually exclusive. But in independent projects, I don't need to do incremental rate of return. I get the rate of return of A, and then I get the rate of return of B. Okay? If rate of return of A greater than or equal to MAR, then alternative A is good. It's justified, economically justified. If B is greater, rate of return of B greater or equal to the MAR, okay, also this is acceptable. But our talk here, our discussion, when we are talking about incremental cash flow, we are using it for what? For a mutually exclusive project. That means I have to select only one project, okay? But for independent project, I just do, as I said, get the rate of return of A and compare it to MAR. If it is greater or equal to MAR, you are happy. Okay, acceptable. That means economically justified. Same thing with B. But with the mutual exclusive, no, I cannot select two projects. I have to select only one project. So how are we going to do that? Let's do an example. Okay, keep in mind, okay, we are going to be doing B minus A. That means more cost, okay, more initial cost minus less initial cost, okay? The rest of these, I'm going to show you, you're going to see it while we are solving. So let's solve this example. Incremental rate of return evaluation. Okay, I have, from the beginning, those are considered mutually exclusive, given. So once they tell me mutually exclusive, and they are looking for rate of return, and because they are multiple projects, it's not only one, it's not only A or only B, therefore I have to use incremental rate of return. So I put my payments like that. Okay, alternative A, we have 40,000, 25,000, cost, and then I have salvage value 8, life year 5. Okay, for the second alternative, also I put all the information, okay, in a table like that. It will make my life easier. And also I insist, and I keep reminding you, that put them in order. Based on what? Based on the first cost. A is less cost than B. Okay? If I have C, and C is, let's say, 70,000, I will put C here. If I have D and it is negative 20,000, D will be before A. Okay? So how are we going to solve this? This is very straightforward. Look what will happen. I have to get now b minus a. Why I need to get b minus a? Because this is the main idea of this. This is the main idea of incremental rate of return. Okay, we're not getting rate of return of a or b. Those are not independent. Those are mutually exclusive. So I have to get b minus a. B minus a, negative 60 minus 40. That means negative 60 plus 40. So it's negative 20. I'm done from this b minus a. As we talked about in previous chapter, everything has to go to 0. Whether it is PW equal to 0, AW equal to 0, or FW equal to 0. You can solve this by using any. Here I want to use what? PW. Okay? So I will set PW equal to 0, and I have to bring all these payments, I have to bring them to another dimension. What is it? The P dimension. So I'm converting all these to PW. And because we are talking about rate of return, PW has to equal to 0. Why? Because we said the PW inflow is equal to PW outflow. That means by the end of the investment, all the payments will be equal to 0. Okay, cash flow, the outflow and the inflow. That's why we put 0. Okay, so now we consider B minus A as, an entity like A or B. Okay, how we usually do it? We say, hey, negative 20,000, it is now. So, and I'm doing everything in which domain? We said P domain, okay? So now it's going to stay now, okay? It's present worth. No need to add any factor. So negative 20,000, negative 20,000. $6,000 now, okay? It is what? It is annual cost per year. So I have to transfer it from A to P. For how many years? 5 years. 5 years is given. Now the second one is, the last one is the salvage value. Salvage value is it future, present, annual. It is future. Salvage usually after I'm done from my alternative. And I want to sell it. So it is $2,000. So I transfer it from the future to present. How many years? 5. So now we have this equation. Okay, this equation. One unknown, where is the unknown? The delta I. And this is very similar to the previous chapter. If you can check the previous lecture, we know how to get it. How we are going to get it? We are going to get it, either you can use Excel sheet, okay? Or we can use trial and error. And the other alternative will be using the formula, okay? The formula. I can show it to you in a second. After I find delta I compare it to the MARR given, which is the MAR, okay? How much the MAR? 15%. Here it happened, delta I is going to be equal to 17.2%, which is greater than the MAR. It's a good investment, okay? But which one I will select? It's a good investment. Okay, in total, delta I is good investment. Okay, but which one? Is it B or A? The rule is as follows. If I sort them from less first cost, okay? I order them. Less first cost to higher first cost, like I have here, negative 40, then negative 60. And I am doing the PW or AW or FW, whatever you are using, okay? To get the delta I of B minus A, that means the more cost minus the less cost. We're talking about initial cost, okay? Then, if delta I B minus A is greater than the MAR, than the MAR, we select what? B. And that's what we have here. Okay? They say if delta I, B minus I, that means the first cost minus the less cost, okay? As first cost we're talking, as you remember. If delta I, B minus A is less than MARR, less than MAR, which one I will select? A. Otherwise, we select B. What does it mean? That means if B minus A is greater, if this is greater than MARR, which one I have to select? B. So let me repeat this again to avoid any confusion here. Okay. Let me show you. Okay. This is just to be aware of. If I have, always I use B minus A. Always I use what? The more first cost minus the less first cost, okay, or initial cost. So if now I get delta I of B minus A and it is greater than MAR, which one I would select? Exactly, I will select B. If delta I, B minus A is less than MAR, which one I would select? A. Okay. So always look at it, guys. Hey, we have B minus A should be greater than the MAR in order to get B, okay? To select B. And that's exactly what happened here. They said, hey, we have B minus A greater than MAR. So I select what? B. Okay. A is not good. A is not good. So this is the way we get the incremental rate of return among two alternatives. But keep in mind one more thing here, that here we are using what? Same life service. Okay, same life service. That means we have 5 years and 5 years. So if it were to be 5 and 10, let's say, I have to use what? LCM. Okay, I have to use LCM. And LCM, we discussed that before. Okay, we have to use LCM. But here we were lucky. Okay, 5, 5, we don't need LCM. And let's assume, for whatever reason, I have 5 and 10. And I don't want to use LCM. What should I do? Rather than using PW, I will use what? AW. How I'm going to use AW? Okay, it's very simple. I can, okay, let's assume we are using AW. What will happen here, guys? If I want to solve it for AW, okay, what will happen? Let's compare it. Okay, this is here PW. If I want to use AW, look at this. Okay, this is here PW. I'm using here what? PW. Now I want to use AW. It's going to give me the same result. That means I'm going to select, if I use AW, which one I will select as well? Also, I will select B. So how I'm going to do it? Okay, I will use this now. I want to use AW. As I said, if you give me a couple, if you wait a couple, seconds, I will show you how we get the delta I. It will be a good review. Here we have a 20,000. 20,000, it is what? It's a present. And I need everything to be converted to a domain. So what do? I say, you know what? We have to convert the present worth into what? Annual worth. So here we are going to say we have to move from what? We have to find the equivalent of that money, in A domain. So we have to transfer the money from P to, convert it from P to A. Okay, that's why we have to multiply it by this factor. Okay? And it's 5 years because it's given 5 years. Now, 5 years because, again, I have a 20,000. It is what? First cost. Now, I'm finding everything in which domain? AW. So everything has to convert to be converted to what? To AW domain. 20,000 is not in AW domain. It is in present worth. So that's why I have to transfer it from P to A. Then I go to A. It is 6,000 per year. And I need everything what? Per year. So I don't need this anymore. Because it is what? Per year. Okay, so this is good because it's already in the proper domain. Now, $2,000, it's in the future. So I have to convert it from the future to what? To A. Okay, and here we go. So now we have two ways to solve it. I can solve it using PW, I can solve it using AW, and same thing with FW. Okay, very similar. Now, how we get delta I? How we get delta I? This here, you know, as I said, we explained it in other chapters, but here I'm gonna remind you about it. Okay, remind you about it. Just a quick note, for revenues alternatives, okay, that means we do not just have annual cost, also we might have annual revenues. You have to keep in mind in certain situations when we have revenues alternative, I have to start with what? With do nothing, okay, with do nothing. So rather than saying, hey, I start with A, the first one will be do nothing. We will later on we'll solve some examples about it. But back to our example here. Back to our example. We solved this based on PW. We can solve it based on AW. We said we can solve it, based on FW. There is another thing we have to keep in mind. That what if we have A, B, C? Basically, what do I mean when I say select B? What do I mean? That means A is not anymore included. Choose what? B. So if I have A, B, C, and I start, let's say, with the C, or let's say we have, okay, let's take an example. We have before A, we have another project called X here. Okay, we have X, and X is negative 20,000. So I will put them in order. And I will do A minus X. So if A minus X and the delta A minus X is greater than MAR, then I will select what? I will select A. Here I select BY because the delta, okay, because the delta, as we saw, was delta B minus A was greater than MAR. So select B. Now, if I have A, B, C, I eliminate A. A is no good anymore. Then after I select B, what do I have to do? I have to do C minus B. Then I compare it to MARR. If I do C minus B now, if it's greater than MAR, which one it will be a winner? C or B? C. Okay, so basically I keep moving on. If I have more alternatives, I go with more, calculation. So later on, I'm gonna show you, more examples about these, and maybe it's a good idea also to keep, the how to get delta I. We keep it for the other session. Okay, but for the time being, let's summarize what we did. Incremental rate of return, we use it because we have a mutually exclusive alternatives. And since we do not know what's our total investment, and we really need to get a real detailed idea of what's happening, So I will get the cash flow, okay, of the alternatives. I compare two alternatives adjacent to each other. Here it happened I have A and B. So I put always my alternatives in order based on what? Based on first cost. So I put A here and all its payments. Why? Because the first cost of A is less than the first cost of B. Then after I put them in order like that, in a nice, neat way, I get the cash flow. Okay, the cash flow here is what? It is B minus A. So now my cash flow that I have to get its PW, AW, or AF or FW, it's up to you. It's this one, okay? Not any more individuals. For independent alternatives, okay, I will get rate of return of A, then I will get rate of return of B. That's independent. And if rate of return, any rate of return that is greater than MAR, then it's a good investment, good alternative. But because here we are dealing with a mutually exclusive, I do the following. I get the cash flow, then I get the rate of return of this cash flow. Okay. B minus A, then I decided to do it using PW. So PW, I will get negative 20,000. It's in now $6,000 of that cash flow. It's annual, so I convert it to present. I take it from A to B. 2,000, it's a future, so I convert it from from F to P. And then I go solve for delta I using Excel sheet, a trial error, or or using the formula. And I think I will show you this next session. If you don't want to use PW, you can use AW, same concept, okay? We put everything equal to 0, and then I have to make sure I take care of the units. If everything has to be in AW domain, then I have to transfer or convert the $20,000 to what? To A. So I have to convert it from P to A, because first cost is what? Is the present cost. Okay, it's now, the money I'm paying now. And the $6,000 is annual, so it is it's annual. Okay, no need for factor notation here. $2,000 you convert it from F to A. Why we have 0 here? Because in rate of return, I'm assuming all the cash flow out equals to cash flow in. So you subtract them, it will be equal to 0. Okay, and that's why we put 0 here. Okay, so whenever we want to search for rate of return, the equation has to equal to 0. And this is the main idea of this chapter. Later on, we'll do more exercises and show you more examples.